So, if you or someone you know is going through cancer treatment, you're probably very familiar with getting routine lab work done. But here's a thought. What if those standard tests are only telling you part of the story? Today, we're going to dig into how a deeper look at your labs can unlock some absolutely critical intelligence, helping you take a much more active role in your own health.
And that's really the big question we're tackling today. Look, standard lab work is crucial, there's no doubt about it. But what if there's a whole other layer of information, a deeper story kind of hidden in your results that could help you and your doctors make even smarter, more informed decisions?
It all boils down to two totally different philosophies. The standard approach is what we'd call reactive. It's focused on the what, like what are the immediate side effects of treatment? But the expanded approach we're talking about, that's proactive. It digs deeper to find the why, the underlying conditions in your body that might actually be fueling the cancer itself.
All right, so here's what we're going to cover. First, we'll talk about the limits of just tracking side effects. Then, we'll get into what a pro-cancer environment actually is. After that, we'll map out the bigger picture, talk about the huge difference between normal and optimal ranges, and wrap it all up with the power this kind of intelligence really gives you.
Okay, so let's start with what most of us already know. What's the main job of the lab work that most cancer patients are getting on a regular basis?
Well, for the most part, these standard labs are all about playing defense. They're watching things like your blood counts, your kidney function, your liver function, mainly to make sure the treatments themselves aren't causing too much damage. And that is, of course, incredibly important for keeping you safe.
I love this analogy. Think of it like a smoke alarm in your house. It's absolutely essential, right? It screams at you when there's a fire, an immediate danger. But the smoke alarm has no idea what started the fire. It can't tell you if you have faulty wiring in the walls that might just cause another fire next week. It's a warning system, not a diagnostic tool for the root cause.
Okay, so if the standard tests are the smoke alarm, how do we actually go check the wiring in the walls? Well, that brings us to the core idea behind this whole expanded approach, getting a handle on your body's internal environment.
And this is where the thinking really shifts. I mean, ask yourself this. What if the very conditions in your body that allowed cancer to get a foothold in the first place are still there? If your internal environment is still pro-cancer, it could make treatment a lot tougher or even pave the way for a recurrence later on.
And that brings us to this really important idea, the pro-cancer environment. Now, this isn't some vague, fuzzy concept. It refers to specific, measurable conditions inside your body that can help cancer grow or help it resist treatment. And finding these conditions is exactly what this expanded lab testing is designed to do.
All right, so we've established the smoke alarm isn't enough. What's the alternative? How do we actually get that complete map of what's going on inside?
Well, this is where we go from a smoke alarm to a full-blown home inspection. Instead of just waiting for a warning, we're proactively checking the wiring, the plumbing, the foundation, all of the body's core systems to figure out not just if there's a problem, but why it's happening and what we can do to fix it.
Now, this expanded approach looks at about 25 different biomarkers. We can't get into every single one today, but let's break down a couple of the big categories so you can see how this works. And we'll start with a huge one, glucose metabolism.
So why start here? Why does glucose matter so much? Well, because we're looking at one of cancer's main fuel sources. Seriously, understanding how your body is handling sugar gives us this incredibly powerful window into the metabolic environment that cancer cells are living in.
And this isn't just about checking your blood sugar once. It's about getting the whole picture. You've got fasting glucose for an in-the-moment snapshot, hemoglobin A1C to see your average over the last 3 months, and even a really cool test called 15AG that can spot recent spikes. Altogether, they give you this detailed 3D map of how your body manages sugar.
Okay, next up is another huge one, inflammation. We hear that word all the time, right? But in the world of cancer, it is a major player.
And let's be clear, we're not talking about the kind of inflammation you get from a sprained ankle. We're talking about that sneaky, chronic, low-grade inflammation that's just kind of smoldering in the background. That's the stuff that can create an environment where cancer can more easily grow, thrive, and even spread.
So how do we measure that? Two key markers really give us that insight. First is hs-CRP, or high-sensitivity C-reactive protein. It's a great general marker for inflammation. And the second one is homocysteine, which, if it's too high, can also point to inflammatory stress going on in the body.
Okay, but here's where it gets really interesting. This is a game changer. It's not just about getting more tests run.
The secret sauce is in how you read the results. And this is where we have to talk about the massive difference between normal ranges and optimal ranges.
You know that normal range you see on your lab reports? It's huge. It's basically designed to tell you if you're actively sick right now. An optimal range, on the other hand, is way, way tighter. It's based on research that shows us the levels that are associated with the lowest risk of future problems. It's about striving for ideal health, not just avoiding obvious disease.
This is where it all clicks. Let's look at some real numbers. For fasting glucose, your lab might say anything under 100 is fine. You're normal. But look at the optimal range, 65 to 85. Suddenly, a glucose of 95 doesn't look so great, does it? Or look at that inflammation marker, hs-CRP. A lab might say anything under 1.0 is low risk, but the optimal goal is to be at or below 0.5. You see? You can be perfectly normal, but still be miles away from optimal. And that gap is everything.
So what happens when you put all of this together? When you combine this bigger panel of tests with this stricter, more insightful way of reading them? Well, you get the power of intelligence.
We're talking about a full picture built from 25 critical puzzle pieces. We've just touched on glucose and inflammation, but a full panel would also dive into things like hormone balance, immune function, and even clotting factors. Each one adds another layer of detail, creating this super clear, high-definition picture of your body's internal landscape.
And this quote really just nails it. This isn't just about collecting data. This is about generating actionable intelligence. It's about finding insights that can help you and your whole medical team make smarter choices and navigate the entire treatment journey much more effectively.
And really, that's what this is all about. It's a shift in mindset, from being reactive to being proactive, from just looking at the what to really understanding the why. It's about arming yourself with the information you need to ask better questions and to be a true partner in your own healthcare. So I'll leave you with this question. What could this kind of critical intelligence reveal for you?